Welcome to this lecture. This lecture is about solving partial differential equations with the help of a built-in solver provided in the framework of MATLAB. The solver is PDETool. So before we start this solver and see how this is going to work, I'd like to give you a brief review about partial differential equations, more specifically the second order partial differential equations, as the tool will be able to solve the second order partial differential equations. So let me give you some refresher about partial differential equations, the second order partial differential equations. So a second order partial differential equation A uxx plus b uxy plus c uyy plus d of xy ux, the first order derivative, e uy plus fu is equals to g of xy is said to be parabolic if b square minus 4ac is equals to 0 for all xy in the domain omega. And this is called hyperbolic if b square minus 4ac is greater than 0 for all where xy in the domain omega, and this equation would be elliptic if b square minus 4ac is less than 0, and this must hold for all xy in the domain omega. So what you see, this is the most general form of a second order partial differential equation. These coefficients A, B, C, which are the coefficients of second order partial derivatives, they take place in this classification. So there is no role of the coefficients that are attached with the first order derivatives or even with this u. If this right hand side is 0, we say this is a homogeneous partial differential equation. If this source term is non-zero, we say this is a non-homogeneous partial differential equation. This value of ABC, this could be a constant as well. If this is constant, then in the whole domain, the character will be same. But if the coefficients depend upon xy, then it might be possible that in some portion of the domain, the equation is parabolic, and maybe in another part of the domain, equation would act as elliptic. So there are certain analytical tools to solve these kinds of partial differential equations. You might have used some transformations to solve partial differential equations, like Laplace transform or Fourier transform. But there are, of course, restrictions when you are using these transformation equations should be linear, and there are certain other requirements. You have the classical tool separation of variables, and there are, of course, other tools. But we will be talking about simulation tool provided in this MATLAB, which is PDETool. So this tool solves partial differential equations with the help of a numerical approach known as finite element method. Okay, let us